Hello and welcome to another lesson from Spiral Physics Education, and we'll be looking at momentum in this episode. We're going to be calculating momentum. We're also going to be looking at the law of conservation of momentum, and looking at a collision example and a recoil example using the law of conservation of momentum. So there's not much that you need to know prior to this, but it's helpful to know about vectors and know that velocity is a vector quantity and that direction is really important when it comes down to momentum and to velocity. So let's start with the definition, and momentum is defined as the product of mass and velocity. And momentum is a vector and it acts in the same direction as the velocity. So it's really important to make sure that when you define momentum that you say it's the product of mass and velocity and it acts in the same direction as the velocity. From that definition, then you can clearly see that because it's the product of mass and velocity, momentum is calculated by just multiplying mass and velocity together. Mass should be in kilograms and velocity should be in meters per second while you're doing this, and that will give you momentum in kilograms meters per second. So let's have a look at a straightforward example. We're going to be calculating the momentum of a 50-gram tennis ball being served at 33 meters per second. So the first thing to recognize there is that the mass is not in the right units, and they often do this when it comes to straightforward questions. They try to just put in something that makes it a little bit trickier, and in this case it's you, the students, being able to recognize that the mass is in the wrong units. So converting 50 grams into kilograms by dividing it by 1,000, therefore the mass is actually 0.050 kilograms. Now we can just plug it into the equation, so we always write the equation down because we're telling the person that's watching this exactly where we're starting from. And to complete the communication, we substitute in the values, and then we have our value of 16.5, and we've got to have the units, kilograms meters per second. So you should always try to show your working in stages like that. Equation, substitute in, answer, and the units. So the conservation of momentum. So it's a little bit wordy, this. In that it's in an isolated system, the total momentum before a collision is equal to the total momentum after a collision, provided there are no external forces acting on the system. So, highlighted some words there. So isolated, and what we mean by isolated, it means that there's no other objects involved. So if you're just dealing with a car colliding with another car, you don't consider a third car or the air or anything else like that. We just consider the two cars to keep it very, very straightforward. The next thing to look at as well is that external forces. And external forces, we mean we're going to ignore friction and air resistance. And that means that we just keep this very, very straightforward. So as long as we just keep it straightforward with the number of objects that are involved, and we also ignore friction and air resistance, this law is always true. So let's have a look at an example considering that. So we have a 30 kilogram, sorry, a 0.3 kilogram ball moving at 4 meters per second, and it's going to collide with a stationary ball with a mass of 0.2 kilograms. And then after the collision, the balls are going to stick together and then they're going to move off with a combined velocity v, and we're going to calculate this unknown velocity v. So that's a little bit wordy, that. So the best thing to do, the best thing to do that I would suggest that you do is to draw a before and after diagram. So this is what it looks like before. And draw an after diagram. And this is what afterwards looks like. Now, personally, I'm a visual learner. I can ignore all of those words and I can look at those two diagrams and I can see exactly what's going on. So what we need to do there is apply the law of conservation of momentum. We can say the total momentum before is equal to the total momentum afterwards. So what that means is mass times velocity of the white ball plus the mass times velocity of the blue ball before equals the combined mass of the two balls together multiplied by their combined velocity or unknown velocity v. So before we have the white ball has a velocity of 4 and a mass of 0.3. The blue ball isn't moving, so its momentum is 0. And the combined mass of 0.3 and 0.2 is 0.5, and we've got that unknown velocity v. So we can solve that, and we get 2.4 meters per second, and it's going to move off to the right, just to put in that vector notation in there. So let's have a look at another example. In this one, we're going to be looking at a cannon firing a ball. And what we're going to do, we're going to calculate something called recoil velocity. So here we've got a 500 kilogram cannon firing a 20 kilogram ball, and the ball is fired out at 75 meters per second. So we're going to draw a before and after. So here we've got our cannon and ball before, and afterwards we've got our cannon, but the ball is being fired out. And because there's a sudden increase in momentum to the right, the cannon must move to the left with the same amount of momentum, and that's called recoil. And the ball is going to move off with 75 meters per second, and we're going to get this unknown velocity v. So that's what we're going to try and calculate. So we're going to apply the same process as we did before. We're looking at total momentum before and total momentum after. So I've color coded this a little bit. So the white shows you the cannon, and the green shows you the cannonball. Okay. And what we have here is beforehand, the cannon and the ball are both stationary. So the total momentum before is actually going to be 0. After though, the 500 kilogram cannon is going to recoil with an unknown velocity, and the ball is going to move off with a velocity of 75 meters per second. So we can simplify that a little bit. 75 times 20 is 1,500. And what we can do is rearrange that, make v the subject, and we get an answer of -3 meters per second. And what that means is the cannonball is going to move off at 3 meters per second to the left. The minus sign there means that the cannon is going to move in the opposite direction to the ball, because we gave the ball 75 meters in that second line, 75 meters per second, a positive sign, and that signifies it's moving to the right if I give it a positive sign. So anything that pops out as negative is anything negative means to the left. So the recoil there is to the left. So I hope you found that useful. Do subscribe to the channel, and there'll be more hopefully useful episodes on to help you improve your understanding of physics and get those grades up to where you would like them. And stay tuned, and see you next time on Spiral Physics Education. Thank you.